Hey there, netstat here. In this video, we're going to go over how to parse procnet TCP, which could be really useful if you have a process running and you want to see what address and port it's bound to. Now, you might be on a super lockdown system where tools like SS, NC, netstat, telnet, and curl aren't installed. And by the way, I've done videos about that using curl to actually make a telnet connection, which is pretty handy if maybe you have curl installed on that telnet. But yeah, this blog post for me is kind of just going to be a little bit of notes. We're going to be jumping between the blog post, running all sorts of different things in the terminal, seeing some outputs there. Right now it's hosted on localhost. By the time you watch this video, it will be available on my site. I'll leave a link to that one in the description. So yeah, use cases, right? Let's say that you're running something, it could be in a container, maybe not, but yeah, it's not working and now you just want to troubleshoot some things and you want to make sure that whatever process that you're running is actually bound to something like 0000 or maybe localhost in this case here. And if you're running your workload in a containerized environment using something like Docker or Kubernetes, that could be a super lockdown system, right? Maybe you're running things as a non-root user, sudo isn't available, there's no sorts of like user escalation there. And then also, yeah, very few utilities might be installed. Now, if you're running in something like a Kubernetes cluster, you can use kubectl debug. This link here has more details about that. We're not going to go into that in this video here, but that lets you analyze the state of another pod or container using a container that you can control. So you can install some of those tools there, but even then that might be super locked down. You can't have access to that, or maybe you can't spin up new containers in the cluster there. So it is pretty handy to be able to read the outputs of these files. So before we go into more details here, yeah, let's take a look at both this one as well as this one and see some of the outputs here. So throughout this video, we're going to go over how to identify, what address and port something on your machine might be running on, just looking at some of the outputs here. So with that said, I've got two different containers. They're both running in Docker, in this case running the Hugo blog that we're looking at right now that is running on port 1313. And then I also have nginx running in a container, which we can see over here. That's basically the container command I ran here just to see some of the outputs that we're going to go over. Don't worry about pausing the video and like copying this. We'll go over more details in a bit here. So it's kind of interesting. We have two different containers running on my dev box now. One of them is IPv4 and the other one is IPv6. And yeah, before maybe we get into that difference here, procnet itself, it's available on Linux systems, and a process will write its address and port information to its protocol file. So there's TCP for IPv4 as well as TCP6, which is IPv6. It is available on Linux systems, including WSL2, but macOS doesn't have procnet available on its file system here. However, with that said, if you are using Docker and running some containerized workloads, you will be able to exec into your container and see its procnet information. So we're going to go have a whole section about doing that in a bit. But for now, if you're on macOS, just hang tight and maybe just watch some video. And then we'll get to the point where you can follow along as well near the end. With that said, there's other different protocols in procnet as well, like UDP and some other things there. You can always check that out later. This is not going to be a deep dive in procnet itself. Now, when it comes to containerized processes with Docker, if you're familiar with Docker, ran some containers here, you might do something like this, where you are publishing port 8080 to your Docker host, and then 80 on the right-hand side of the colon there, that is the port that's bound inside of your container. Pretty common thing to do, you might see out in the wild here. And, if you omit any type of address here, it is going to fall back to using : here, which is an IPv6 wildcard socket, or, more commonly you might think like 0.0.0.0, which is pretty interesting because as far as I know, Docker will bind to this, which makes this compatible with both IPv4 and IPv6 traffic on basically any address. So with that said, I wanted to call this out early because yeah, if we go back to the output here, you'll see one of those processes running here is on TCP6, whereas the other one is on just TCP. And, this kind of clarifies it a bit. You may have also seen this type of syntax here when you're running a container. You can publish a port to, let's say, localhost specifically, 127.0.0.1, and then we do : 8080. So this is actually being published to localhost here on this port. And then again, to the right of the rightmost : port 80 there is inside the container. So when you do a binding like that, then yeah, Docker will actually use an IPv4 socket, and you'll find it in procnet TCP. So if we actually go back to here, that's why we see one of them like this. And in fact, if we actually jump over to the second tmux window here, you can see I'm running this, official nginx, like latest release, basically using Debian Bookworm here. You can see we are using that exact syntax here where we're doing, localhost : 8080 and then : 80 on the right here because yeah, nginx is running on port 80 there. So when we do that, this one actually on top is nginx, and down here is actually the Hugo blog that I'm running in a container here, which is powering this blog post that we're seeing right now. But yeah, I just wanted to include that as an important detail ahead of time here. You might be wondering, like, how come, why is it sometimes in TCP6 versus not, if you're running a containerized workload? It depends on how you're publishing your ports, basically. So yeah, let's start parsing the output of that. And by the way, parsing the files themselves are the same, just slightly different values you might see here. And there's really only going to be one output that we're going to be looking at here, but there's all sorts of different outputs here. It's kind of cluttering the screen because the font size is super zoomed in. The good news is we're really only going to focus on this local address column, which correlates back to that. And then for TCP6, same deal, local address as well as that. Everything else we sort of kind of don't really need to worry too much about. Although the state of this system here, this is basically in listen mode, could be, useful to know as an aside. But yeah, we're going to be focusing on that and that. So let's go back to the post here. And yeah, that's the state of my system on the dev box, blah, blah, blah. This first entry here, TCP6, this is Hugo, published on 000013. Basically, I just ran, like a -p and then 1313:1313 to spin that up. And then Nginx, as we saw there, it was bound to this on the host here. And that is the output that we see here. So the interesting takeaway here is, yeah, we just need to do a little bit of conversion from 16-bit hexadecimal to decimal. So, if we go back to over here, this is what we're looking at here. So both of these values here, both the address and the port, they are in 16-bit hexadecimal form, and we just need to convert those back into decimal so that, we have a mental map of what those are, as what we might think them to be. So if we go back to the blog post here, there's all sorts of different ways that you can do this. And by the way, as mentioned here and a second ago here, like the port is just separated here by the colon in both examples here. And yeah, we can just use printf, and there's all sorts of other tools. You can use echo with some like modern bash features to do conversion. There's all sorts of different tools that you can use, Perl, etc., online converters. But I find printf to be pretty nice. It also works on macOS as well to do some of this stuff. So yeah, let's go and actually just convert some of these to decimal format and see what they are. So in this case, we're just doing printf. We're going to be printing decimal here on a new line, and then we just need to pop in the hexadecimal value that we want. The only takeaway here is that, yeah, you want your value to start with 0x, and then put in basically whatever you see to the right of the colon here. So in this case here, that's 1313. This is that Hugo server that's running on IPv6, because again, it was just published with basically this, 1313 and then 1313, something like that. And yeah, the other one we can just go and do 1F90. And I'm reading that up from over here, 1F90. It's to the right of that colon. And we would expect to see 8080 there, because if we go back to here, then yeah, it is port 8080. So now, let's go back to the blog post, make sure I didn't forget any super important details. Nope, we're just going to go and take a look here at the address, which is not harder to parse, but, a little bit more information, but same exact type of thing. So we have this IPv6 basically wildcard. And this one's sort of easy just mentally looking at it. You can be like, oh, if there's like a billion different zeros there, then it's basically, a wildcard on any address there. The more important, or I guess the more interesting one potentially here would be like the IPv4 one. So this actually translates down to 127.0.0.1. But how does that work? So, maybe just is a little bit easier to look at here. If we do something like, 010000 and then 7F, and then we just echo that out, we can basically see the same string as we do here, but with some spaces, which could be a little bit more useful to parse as a human. You can think of these as, each individual byte. And it's actually in reverse. So what's funny is, this 7F is actually 127, then we have 0, and then we have 0, and then we have 1. And we can do the same type of calculations we did before here at printf or whatever to convert that. So let's just start with, backwards, I guess, or forwards in this case. There's the 1, there's the 0, there's the other 0. And then here is going to be, what are we putting in? 7F. And that is going to be the 127. So if you just reverse this entire sequence, then you get 127.0.0.1. And then, yeah, it's using something like little endy in there to do the formats there. That's why, or it's stored in this format here. You can read more about that on Wikipedia, whatever. I'm not going to get into the gory details here, but yeah, this blog post basically just says, how the workflow you could use to basically do it, right? Break it up into bytes, reverse it, and then convert each byte individually, and then boom, we arrive at our solution there. And yeah, actually kind of funny enough, right? A lot of times a process could be bound to something like localhost, and you'll be able over time just to look at that and be like, oh yeah, I know that's localhost there. But in other cases, though, maybe you have a whole bunch of different entries in procnet TCP, right? On a live system that you might be debugging, there could be 5 things there, 20 things there. It really depends, right? And maybe you just want to look for a specific port, right? You can always just grep out whatever port that you want in procnet. Well, I just put a typo there. That should have been TCP or TCP6, depending on what you're doing. But you're going to have to grep for the hexadecimal port. And, if your thing is running on, I don't know, 5432, like Postgres or something like that, you can't just grep for 5432. You need to first convert that into hexadecimal. So this printf statement here is going to do just that. Kind of similar to what we just did. Whoops, clipboard got killed. There we go. And boom. So now we basically are doing the opposite, where we are passing in a decimal and it's being converted into hexadecimal. So the syntax for that is basically this, using printf. Again, many other different tools that you can use to do here. But what's really cool is we were looking at some other things here. Let's verify those, because the 5432 is kind of new for us here. But yeah, let's put in port 1313. We would hope to get 0521, which is the exact hex value that we see here. And then for the other one, 8080, let's see if we get, 1F90, 1F90. So now we have a reversible sequence here, allowing us to get the information in both different ways, which is exactly what we want here. So yeah, pretty handy here, right? Now you have enough information to do that basically. And with that said though, if you do have something like SS installed or another tool like netstat, I think that might be installed in macOS by default. I'm not 100% sure. The flag's always different with some of these tools. But yeah, you run something like this and it's like, well, now you don't need to worry about byte sequences and, hexadecimal conversions. Is basically, oh, there's a local, address and port here, and you have all the information that you need. But yeah, again, focus of this video is not if you have those tools. Of course, if you have them, then use them. But yeah, in this case here, we were able to get this information out in a pretty quick way. And then, yeah, you just need to convert this stuff as needed depending on what you're working on. Now, with that said, let's follow along a little bit, running some Docker containers together and looking at the outputs of procnet inside of the container there, because it will further drive home maybe some of these examples here about publishing ports and hosts and inside the container and all sorts of things like that. So yeah, this command that I ran here was the exact same command that I just ran over here in the second terminal. Same exact thing, right? We're just running it, giving it a name. There's our localhost publishing there. And then, yeah, that's the image there. Cool. Okay. So let's go back to the blog post. And what does it say to do? So in a second terminal, we can just run this. So let's do that. I'll just bounce over to here so it's a little bit easier to see together. But yeah, in this case here, we are actually just catting out the same procnet TCP file that we looked at on the host, but remember now, this is actually running inside the container. So if you are using macOS and you have Docker installed and you're following along, you will be able to run this command and you will see the outputs that we see over here. But the outputs might look a little confusing, because here we're looking at the local address and it's like, all zeros and then 0050, but it's like, no, what happened to the other one? Like the other port, the 8080 port. And yeah, let's go back and run some printfs here. So we can take a look here at 0050. What is that? Oh, interesting. That's 0032. Okay, well, I did that in the wrong order, by the way. Whoops. Let me do the other printf. We actually have to pass in the hexadecimal format, which would be 0050. And yeah, that's going to be port 80. And here, the zeroed out one, that is 0000. Because again, if you look at the bytes there, that's byte 1, that's 0. And then we have byte 2, also 0. And then 3, 0, and 4, 0. And you can put the dots there in your mind, and it's like 0.0.0.0. So in this case, though, does this make sense? Yes, definitely, because we are executing this in the context of the Docker container. So we ran this command here, but if you look at the right-hand side, Nginx is bound to port 80 inside the container. That's set up by the folks who are maintaining this official Nginx image here. And yeah, if we go back to here, then we also have this zeroed out because it's also bound to 0.0.0.0 inside of the actual container itself. It doesn't matter, on the left-hand side, this is the host information. This won't be in the output of here because, this is the output of the container side things. So yeah, that makes a whole lot of sense here. And if you take a look at the other TCP6 inside the running container, you'll also see the same thing. There's port 80 and there's, basically that wildcard, whatever the 0.0.0.0 equivalent is for IPv6, like the 2 colons or whatever it is. With that said, that makes sense also because, yeah, this official Nginx image also binds on IPv6 inside the container itself because, it can serve traffic for both unless you, change around your configuration, which I didn't. In this case, I'm just using the out-of-the-box config. So yeah, that kind of gives you some details about the differences between, how things are working on your Docker host or inside the actual container itself. All this basically just goes over what we said here. But yeah, I just wanted to include that here because it could be helpful just to be able to distinguish both of them. But yeah, with that said, let us know in the comments below if you're ever going to be parsing this file by hand, or maybe, the last time you had to do something like that. I actually had to do it pretty recently last week, and that's why I'm making this video now, because it's a little bit fresh in my mind. With that said, if you have any questions, I'll do my best to answer them in the comments below. If you like the video, please give it a thumbs up. It really does help a lot. Thanks a lot for watching, and I'll see you in the next video.